Hi everybody! So in today's video, I'm going to be going through some of the big topics and ideas that we need to understand in order to be ready to try the 4.4 Ready, Set, Go practice problems. So in order to get ready, we're going to start by talking about how to represent a graph using interval and inequality notation. Now, the good news for us is that interval notation is something we already learned. So this is a review of something that we learned in Module 3. And what we learned in Module 3 was that we can represent groups of numbers using parentheses and brackets. We're going to use a parenthesis when it's an open circle or when we have a positive or a negative infinity. And we're going to use a bracket when we have a closed circle. If I want to use interval notation to represent this graph, what I like to do is kind of make some notes on the graph of exactly what are the important features would be. So on this graph, I'm noticing there's an important thing happening at the -1. And I'm noticing that because there is a circle, which happens to be open, on the -1. I'm also noticing that there's an arrow after the shaded region that points to the right. And I know that on a number line like this, if I go to the right forever, I'm going towards positive infinity. So if I wanted to represent this interval, here's how I would do that. I always start with the number that is farther to the left on the number line. So the orders I put them in here are going to be the same as the order they are in the number line. The first number in my interval is going to be -1, and then the second number is going to be infinity. Once I have the numbers figured out, I just need to think about whether this should be a bracket or a parenthesis. Since this first circle is open, I'm going to use a parenthesis. And since this last number is infinity, I'm also going to use a parenthesis. This is how I can represent all the numbers between -1 and positive infinity using interval notation. Now, the second thing that we're going to talk about today is what's called inequality notation. Inequality is a new thing, and there are some special symbols that we need to know. The symbol that looks like this is a less than symbol. The symbol that looks like this is a greater than symbol. And we can always do a less than or equal to or a greater than or equal to. By combining these symbols with the idea of an equal sign, which we've already learned about. Now, just like here, where we used open parentheses and closed brackets depending on the type of circle we have, we're going to use different symbols depending on what we're seeing on the graph. If we see that the graph has an open circle, we're going to be using either a greater than or a less than. And if we see that the graph has a closed circle, we're going to use either a less than or equal to or a greater than or equal to. So closed circles are when we have an equal to, and open circles are when we do not have an equal to. We can also decide whether we want a greater than or a less than by looking at the shaded part of the graph. So we're going to use a less than when the shaded part of the graph points to the left. And we're going to use a greater than when the shaded part of the graph points to the right. So, if I were to try to write an inequality to represent this situation, the way I would start is always with the variable x. And then the important number from the graph, which is the same important number that I have here, the -1, would go next. My job is to fill in the symbol that goes in the middle with an inequality symbol. In this case, because the arrow on the graph points to the right, I would use a greater than symbol, because the shaded part of the graph are all of the numbers that are bigger than the -1. Then, because there's an open circle, I would just leave it like this. I'm not going to put a little equal to symbol underneath there. If this was a closed circle, I would put a little equal to symbol underneath there. The next thing we need to do is to practice creating our own graph. So in this scenario, I gave you a picture and said write the notation. In this scenario, I'm going to give you the notation and say, can you create a picture? When you're making your own graph, there are 3 important steps. The first is to decide what number is important on the graph. The second step is to decide whether you have an open or a closed circle at that number. And the third step is to shade to the right or shade to the left, depending on the symbol. So let's go through those steps for each of these problems. In this first problem, the important number here is -3. So on my number line, I'm going to label -3. Now the rule that I have is you always have to show me 3 numbers. So if -3 is the important number, then what I'm going to do is label one number bigger and one number smaller. The number that would be to the right would be -2, and the number to the left would be -4. So I've got 3 numbers on my graph. Now I need to decide if it's an open or a closed circle. Because this symbol has the equal to symbol right here, this is going to be a closed circle, which means the values that I'm looking for could be equal to the -3. Finally, I need to decide whether to shade to the right or shade to the left. I'm going to shade in this case. I want to find all the numbers that are greater than -3. So because I'm looking for the numbers that are bigger than -3, I'm going to shade to the right. If I was trying to do problem 3 and graphing this inequality on a number line, I'm going to go through the same 3 steps. So first, I'm going to look for where the important number should be. In this case, my important number is a 2. I also need to label 3 numbers, so I'm going to label one number bigger and one number smaller than that. One number to the right would be 3, and one number to the left would be 1. Next, I'm going to decide if this is an open or a closed circle. Because there is no equal to here, I'm going to make this an open circle because we do not need to include the number 2 in our choices. Since this says x is less than 2, we want to find all of the numbers that are lower than the number 2. On a number line, that means we would shade to the left. Next, we're going to do problem 4. Now, problem 4 is a little bit different. Instead of giving you an inequality and asking you to graph, I'm going to be giving you interval notation. So, I need to think about how to convey this information, that the numbers go from -1 to 4 and include the -1 and don't include the 4 on a number line. Here's how I'm going to do that. I'm going to start by identifying my key numbers, just like I did with my inequalities. I need to make sure that I can label the numbers -1 and 4. So here's how I'm going to do that. I'm going to start with -1 here, and then I'm going to count up to 4. So 0, 1, 2, 3, 4. As long as you're showing me 3 numbers, which I have more than 3 here, we're good to go. Next, I need to decide if it's an open or a closed circle. In this case, the -1 is going to be closed because this has a bracket. And the 4 is going to be open because this has a parentheses. Now, this notation means I want all the numbers that are in between. So instead of shading to the right or shading to the left, I'm going to shade in between the 2 values that I've identified. For problem number 5, I'm going to graph the numbers represented by this notation. Now, in this notation, the two important numbers are negative infinity and 3. Now, negative infinity is not a number I can really label on my graph, but I happen to know that negative infinity lives over here. The number 3 is, however, a number that I can label, and just like before, I need to see one number that's bigger and one number that's smaller than the number that's important. Next, I'm going to decide whether I have an open or a closed circle. Because this is a bracket, this is a closed circle. And then I need to decide where to shade. Because I want to go from negative infinity to 3, and the negative infinity is on the left side, I'm going to shade the numbers that are on the left of the number 3. And then I'm going to draw an arrow to show that it keeps going forever. Okay, so now that we've talked about the different notation and symbols that we're going to be using, let's talk about some of the words that we use to describe their meaning. If I give you a word sentence, for example, I am thinking of a number that is at most 12, and I ask you to translate that to a math sentence, the first thing we need to do is find the important words here. Because the words is at most are in the problem, those are the words that give me a clue about the type of symbol that I should use. So I'm thinking of a number, so I'm going to use the letter X to represent my number, that is at most the number 12. Now I need to ask myself, if I need at most 12, does that mean I need more than 12 or less? Well, I like to think about money. So if I need at most $12, it means I need less than or equal to $12. So at most means less than or equal. Next, I'm going to circle the numbers that satisfy the statement. So the number 10 is less than the number 12. So is the number 11. The number 12 I really have to stop and think about sometimes. Because this is less than or equal, I get to include the number 12 in my answer. If this was just a less than, I would not include the number 12 in my answer. For number 7, it says, I am thinking of a number that is greater than 4. So I'm thinking of a number, which means I'm going to use X, that is greater than 4, and I'm leaving some space for that symbol. Is greater than is a little bit more obvious than the words is at most. Is greater than means literally greater than. I want the number I'm thinking of to be bigger than the number 4. So now if I want to circle the numbers that apply, 0 is not bigger than 4, neither is 1, 2, or 3. 4 I need to really stop and think about, but because there's no equal to, it's not going to be included in my answers. In this case, only the number 5 is bigger than the number 4. Next, it says, I am thinking of a number that is no fewer than 2. Now, no fewer means that we don't want numbers that are less. So I'm thinking of a number that is no fewer than 2. If we think about having 3 options, we have the numbers that are bigger, the numbers that are smaller, and the numbers that are equal. No fewer means we don't want the less than. But we are still left with 2 options, greater than or equal to. So I'm going to go ahead and circle the numbers that are greater than or equal to the number 2. In this case, 0 is not bigger than 2, and neither is 1. 2 is not bigger than 2, but it is equal. So 2 is part of my answer choices, and then 3, 4, and 5. Last but not least, let's do some practice problems, or sorry, not last, almost last but not least. Next, I'm going to give you a math sentence and ask you to write a word sentence. So if my math sentence says X is less than 0, then that's what we're going to write on our paper. We're going to say X, and then we're going to say is less than, and then we're going to say 0. Again, the numbers that satisfy this would be -3, -2, -1, and then not the 0 because we don't have a less than or equal to. For problem number 10, I would say x, and then I would say instead of is less than, this symbol means is greater than or equal to 36. So because this has a greater than and the little number underline, I need to say is greater than or equal to. So on this list, none of these numbers are bigger than or equal to 36, which means I'm done. We're going to skip number 11 for now, and let's jump down to the last set of practice problems, which is getting us ready for the go. We're going to read these scenarios, and we're going to try to decide what is wrong, what is right, and which student is correct. So this is all about how we justify our answers. So justifying here, explaining, is going to be really important. Number 16 says, a student was asked to graph x is greater than or equal to -4. And this is what they drew. Would this be the appropriate graph? When I'm doing these problems, I need to think back to what I would do if I was asked to graph this. I know that I'm going to think about 3 things. 1, what number was used? 2, is it an open or a closed circle? And 3, which direction did I shade in? So if I'm going to try to decide if this person's right, those are the 3 things I'm going to check. First, what number did I use? In this case, I should have made -4 the really important number where the point, the circle, goes on my graph. If I'm checking this person's work, what I noticed is that they put the number at -7. Well, that's definitely wrong. As soon as I find a mistake, I can stop and I can answer the question. First, would this be the appropriate graph? So first, let's answer the question. This graph is not appropriate. Then we're going to explain why. So justifying your answer is going to mean explaining why. In this case, it was the fact that they used the wrong number. So I'm going to say that in words. I'm going to say the closed circle should have been on the -4. And that's what was wrong with the graph. Now, a slightly different way that we're going to ask you to justify your answer is in number 17. The students are asked to express the following graph with correct notation. So they're given the graph. Student 1 says that we could write x is less than 2, and student 2 says we could write 2, infinity. Which student is correct to justify your reasoning? Just like before, when I'm writing my notation, I always have to pay attention to 3 important things. What number is used? Is it open or closed? And did they shade or in this case, where did they shade? If I look at this graph, I'm noticing there's a closed circle on the number 2, and they shaded to the right. For student number 1, they said x is less than 2. Now, I'm not thinking that that's correct. I'm thinking that's the wrong answer. And the reason is because x is less than 2 makes me think that it's on the right number, but this should have been an open circle, and they should have shaded to the left. So there's 2 things wrong with this. This is not pointing the right direction, and it's not the right kind of symbol. Student number 2, however, put the number 2 as their important number. They used a bracket because this was closed, and they did positive infinity because they shaded to the right. So if I ask you which student is correct, that's what you're going to say. You're going to say student 2 is correct. And then you're going to justify your reasoning. 1, the point is located on the 2. 2, they used a bracket because it is a closed circle. And 3, they used infinity because the graph is shaded to the right. So, to summarize, if you're telling me would this be appropriate, a yes or no question, is it right or is it wrong? If the answer is right, you're good. And if the answer is wrong, you just have to tell me what's wrong. If you're deciding between 2 students, you have to tell me why what they did was correct, which means you need to address all 3 of these things that they did right. Is it the right number? Is it open or closed? Did they shade to the right or to the left? Thank you so much for watching the video. I know this is a longer one. I appreciate it, and I will see you guys in class for some practice. Thanks.